Greetings and welcome, friends. Mr. Waddy here and my Algebra 1 buddies. We're all just talking about exponential growth and decay, as you would, when you're hanging out with friends. And we're in section 6.4. If you want to follow along, you're more than welcome to join us. And here we are. It says exponential growth and decay functions. Now, it said exponential, so that means there's going to be a variable in an exponent, right? Because we've done exponential functions, but now we're talking specifically about a model with growth and decay. So it says exponential growth occurs, so that sounds like bigger increasing, all right, when a quantity increases by the same factor over equal intervals of time. All right, so these are exponential functions in a particular type of modeling when I'm relating it to time and growing. All right, it's exponential. All right, so the exponential growth functions is a function in the form of y equals a times 1 plus r in parentheses all to the t, where a is bigger than 1. Okay, so it's not a negative, right? So if it's bigger than 1, that means it's not going to have flipped it, right? It won't have done that. And r is greater than 0. So that means 1 plus some number bigger than 0, that my base, right, the thing that's being raised to the exponent, is going to be overall bigger than 1. So this is always going to be an uphill, right, Mario runs to the right sort of problem. And our y-axis, our x-axis will be time, and our y-axis will be whatever quantity is increasing that we're talking about. So it might be money, it might be a population, whatever the case may be. We've already seen some of these, in fact, but the only difference is they've broken our base. Actually, I'll even write that. Tell you what, our base is now broken up into this 1 plus r situation. Actually, I'll even write the r in blue. Ooh, right. So the base is the 1 plus r now. Okay, and it says it is an exponential growth function. And so some of the things they told us is r is the rate of growth. Notice keyword in decimal form. So if your rate was, say, 4%, like we were talking about earlier, then r would be 0.04. All right, 0.04. And I am actually always a fan of putting a 0 in front of your decimal point. Technically, you could say 0.04. But I feel like it's just better to throw that leading 0 in there. It will feel safer. So just in terms of naming conventions. A is going to be the initial amount. So that's kind of like our y-intercept that we were talking about. All right, so the A, right, is the initial amount. That's the starting population. That'll be our y-intercept. The final amount will be y, all right, the output, whatever the height is of this curve, based on the input of time, right, which is our x. And it turns out that when I add the 1, or like 100% plus the 4% and get 104%, that the growth factor is when I add those together. So like 104% would be the growth factor, right? 1 plus 0.04 is 1.04. So here is the growth factor. It's increasing, right, by 4% per year. It's 104%, right, each time. So there we go. So exponential functions. So let's put these to work, friends. Ooh, I've got an example here. How convenient. I just happen to be teaching about this, and then like an example is just ready for us to look at. Let's look at example 1. Using an exponential growth function. Let's see. The inaugural attendance of an annual music festival is 150,000. I'm assuming that's measuring people. The attendance Y increases by 8% each year. Write an exponential function that represents the attendance after t years. Interesting. So for part A, the starting value was 150,000 people. So my starting value is 150,000 people. Okay? Now the rate, all right, actually I was doing rate as blue, wasn't I, is 8%. But how do I represent 8% as a decimal? 0.08. Okay? So let's write this equation. That's going to be y equals 150,000 times 1 plus 0.08. All... No, I think I got it right. Yeah. Yeah, you could throw the comma in there if you want, just to keep track of things. And we theoretically, sure, why not? Let's simplify this. What is 1 plus 0.08? That's going to be 1.08 to the t. And so I'll even just call that our growth factor. I'll call that b, our base from earlier, is the 1 plus the 0.08 or 1.08, right? That's our growth factor that we were talking about earlier. Right? So here's my equation. Now they ask me part B. Oh, how appropriate. A to the B. How many people will attend the festival in the 5th year? Okay, so in the 5th year, what is t equal to? Now, it said we were measuring after t years. These weren't like 20-year periods. These weren't 5-year periods. So in the 5th year, t is just straight up 5, right? And so what I'm going to do is plug in 5 for t. So let's see. Y equals 150,000 times 1.08 to the 5th. And let's see. Let's actually have you guys grab some calculators. I'll pass them out. Hang on, internet friends. Wrong then. All right. I'm back, friends. All right, so what we're going to do is let's do the 1.08 to the 5th power. All right, so I'm going to do, turn on my calculator, 1.08, and then a little caret button, little button like this. Up, 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 up. Or sometimes you have a button that says y to the x. I've seen both types of buttons. So 1.08 to the 5th. And this is what I end up getting. I'm not gonna plug this all in at once. I just wanted to figure out what is this piece equal to, and I get 1.469. Oh wait, they said round your answer to the nearest thousandth. Yeah, perfect. So I rounded out to 3 places. So the 1.469 is the growth factor. That means it grew by 46.9% in 5 years. Okay, is what that means. And now what I'm going to do is multiply those two things. And so if I just hit multiply, notice it says ANS. When you hit multiply, that means it's taking your previous answer, and I'm multiplying that by 150,000. And I've got y equals 220,399.21. And then it says 15, because that 5 is 5 or greater. I'll round this out to 2. All right, so this is the number of people that attend the festival in the 5th year. I feel bad for whoever's like the 0.212 of a person. Right, that would be the predicted amount based on this model. And so then if you are someone who is, right, coordinating this festival as far as the number of porta potties you order, as far as the number of hot dog stands you got, the number of pretzels you're selling, the balloons. Oh, gotta have the balloons, right? You're gonna base it off of this number in 5 years. Okay, so that's how it works. It's an expensive party. Let's see. Ooh, let's take a look at this one. I want to do like a few of these examples. I'm gonna try to do these quick-ish. Did they say thousands? Oh, with the save. Thank you. I thought it said 1,000, right? But it doesn't. So yeah, so I would say 224 people. Aha. Thank you with that save. You got to stay on top of me, guys. You don't know when I'm going to make a mistake. Don't just assume because I'm a math teacher that I'm always right, because I am not. All right, here's example 1. A website has 500,000 members in 2010. The number Y of members increases, so that sounds like growth, by 15% each year. Write an exponential growth model. We'll just do part A of this for right now. So let's see, each year, and let's let T equal years after 2010. That means when T equals 0, it's 2010. All right, you got that? So let's see, starting population is 500,000, so that's what the A is equal to. My rate is 15%, so R, how do I write 15% as a decimal? Nope. 0.15. Yep. And if we wanted to, we could already pre-figure out the base. It's just going to be 1 plus 0.15 or 1.15. So that's our growth rate. That's an R. Yeah. You'll get used to my sad-looking R's. So let's see. So I'll have my equation is Y equals 500,000 times, and I could have written the 1 plus 0.15, but I'm just going to already simplify it here. Well, I'm not even going to do the next part anyway, so I was just interested in, can we set these up? Set it up! All right, because I just want to equip you guys with lots of little examples. All right, guys, I don't know if you knew this, but things don't only grow. Sometimes things decay. You know that? Sounds sad, but it's true. Things decay. And exponential decay occurs when a quantity, such as bone mass in an astronaut, decreases by the same factor over equal intervals of time. Actually, I have no idea if bone mass decreases exponentially. But I do know that the caffeine in my system that I drank this morning, that decreases exponentially as my body processes it. So, things like that. Exponential decay functions are of the form, hey, this looks really familiar. A times 1 minus r to the t, where a is greater than 0 and r is between 0 and 1, is an exponential decay function. And everything is the same. So notice a minus sign, and notice my rate was a rate of decrease. Okay, so this is a rate of decrease. So the word decrease is going to be the key word that I recognize. Decay, decrease, right? You got it. So let's do this, friends. Example 2 with the two-iness of the solving the problem. Here we go. All right, that wasn't the best jingle I've ever written, but it's okay. It'll just be like track number 4 on my CD that I'm releasing. It'll be fine. People will deal with it. It says, determine whether each table represents exponential growth or an exponential decay function, or neither. All right, so here the question is, all right, this is decreasing, but it doesn't necessarily mean it's decay, because it could have just been like subtract, 180? Yeah, it could have done that. But 90 minus 180 is not 30. So the question is 270 multiplied by what would give me 90? All right, 270 multiplied by what base would have given me 90? And so divide both sides by 270. I'm going to get b equals, what is 9 divided by 270? And I get, actually, oh, I could have just canceled out the zeros. Man. Yeah, cancel out the zeros. I get b equals 9 over 27. 9 goes into 9 once. It's 1/3, no, 1/30th. Yeah, wait a minute. What am I doing wrong here, guys? I just did something crazy wrong. Wait a minute. This is 1... Right, which is what I'm doing. I'm just trying to figure out why. Doesn't my cancel out the zeros thing work? But I'm getting 1/3 when I do that, but I should have 1/30th. Am I doing something wrong? Huh. Well, either way, I divide it, I get 0.03 repeating. Okay? Right, or it's a third. No, it is a third. Yeah. Maybe I must have entered it in wrong. Yeah, it's a third. It's 0.3 repeat. Why was I so confused? Guys, why am I so confused today? Yeah, that must have been it. So anyways, yeah, it's 1/3. Yeah, you're dividing by 3 or multiplying by a third. And yeah, because 90 divided by 3, yeah. All right, there we go. So this is, but also notice it's decreasing. All right, it's decreasing. So it must be exponential decay. But the weird thing is, if I wanted to find the rate, actually maybe I won't even go there, because that would just be weird. Well, the base is equal to 1 minus the rate. You guys agree, right? For an exponential decay. If this is 0.3 equals 1 minus r, how could I solve for r? I would have subtracted the 1. This is weird. I guess I'll still work in this color. So I'd have 0.7, negative 0.7 equals negative r, and therefore positive r would have equaled 0.7. So it's decreasing by 70% per x, all right? And it's exponential decay is what's going on. All right. But they didn't ask for that. They just wanted to know, is it decay? And it was, because it was getting smaller each time, and it was exponential. All right, let's... Man, with my mistakes, that just took way longer than I needed it to. My bad. So these are equal intervals. And let's see, 5 plus 5 would work, but 10 plus 5 is not 20, so that doesn't make sense. So guys, so what do you think? 5 times what would equal 10? Yeah. All right, so this is going to be exponential growth, which also, I didn't label this one. This one was decay. I guess I should answer the question, shouldn't I? Because I divided both sides by negative, or I opposited both sides to get the positive r. So if, here's the growth, the base is equal to 2, right? Or the growth rate, it's doubling. But if I did want to find that in terms of r, I just want to point out, right, if the base is equal to 1 plus r in this case, because of the growth, 1 plus r, and I wanted to solve for the rate, I could plug in 2 for the base. And how could I solve that for r? Subtract the 1 from both sides. And I'd end up getting r equals 1. 2 minus 1 is 1. Which I want to point out is the same as 100% increase each time. All right, they didn't ask for that, but I just wanted to point out, like, we could technically find this. This was a 70% decrease, and this was a 100% increase, which is the same as saying doubling. All right, so if my bank account increases by 100%, I also could tell my friend, my bank account doubled, right? And then I'd have that as my claim. Okay. All right, let's get to example 3 here. Yeah. All right, it says determine whether each function represents exponential growth or exponential decay. Identify the percent rate of change. All right, so for this one, the base is the 1.07. Because this is bigger than 1, this is actually going to be growth. All right, so that's that. And if I want to find the rate of change, like we were just doing earlier, in a growth problem, the base or the growth rate is equal to 1 plus r. So I'd have 1.07 equals 1 plus r. To solve, I'd subtract 1 from both sides, and I end up getting r equals 0.07. That means this is a 7%, and because it's growth, that means increase for this problem. And notice there you can kind of see the 7% hiding right there as well, right? Now this one's a little trickier. The base is 0.98, which is between 0 and 1. So it's decay. Decay. And if the base in a decay problem is equal to 1 minus r, now if 98% remains each time, what was the percent decrease? That's the question. Right? If 98% of the population remains, what percent was it decreasing by? If I only paid 98% of the cost for Pokemon Sun, what was the discount? It was a 2% discount. And we're going to see like that our logic of 2% is going to work out here. If I do 0.98 equals 1 minus r and solve, subtract 1 from both sides, I would end up getting 0.98 minus 1. The signs are different, so I'll just subtract them. 1 minus 0.98 is 0.02, and I'd take the sign of the more influential. And so the opposite of r, or negative r, is negative 0.02, which means if I flip those signs, r is going to equal 0.02, or this is a 2%, and because it's decay, that's a 2% decrease. Right? We're over here, because this was growth, this was a 2% increase every t time. Years or months or minutes or whatever time happens to be. Okay? So it all goes back to that big idea. Can you realize that 98% remaining is the same as 2% being taken away? Or 107% resulting was the same as a 7% increase. Right? That's the big idea. And it's the decrease ones that are a little bit weird. Let's see. And I don't have to do compound interest. I think I made it through everything I need to. Yeah, don't have to do that. Yeah. We're good. All right. Well, thanks for watching, Internet friends. We're going to try some class quest problems real quick. Have a good day. Bye-bye.